Hi, this is Kent from Man About Tools, and today we're building plywood molds to cast our own concrete garden box panels. These panels link together to create long-lasting, rot-proof garden boxes. If you're like me, then you've made many wooden garden boxes only to see them rot away over time. Now I know wooden boxes have their place and they're cheap and easy to build, but they just don't last. I've used plastic liners, made them from longer lasting red cedar, bought a truckload of cheaper culled lumber, and no matter what I do, they still rot away. So I decided to try to make some boxes from concrete. One option is to build plywood frames, stake them into the ground and pour them in place, in a similar fashion as pouring building foundations or retaining walls. That does work well, and I like that option if you have the materials. But today, I want to make a more decorative, unique garden box, one that might be more suited for flowers or closer to the house instead of a large vegetable garden. The panels that I make interlock in the corners in a straight line or at a 90-degree angle. I cast in plastic pipes so they lock together with rebar. Pouring your own panels gives you the flexibility to modify this simple design to your liking. You can easily change some of the dimensions to make them longer, shorter, taller, or thinner. You can also combine panels of different lengths, as I'm going to do in this video. I have two identical molds that make a 48-inch long panel that is 8 inches tall by 2.5 inches thick. Today I'm going to make 4 similar panels, but I'm going to shorten the length to 36 inches. I have plans available for download from my website, manabouttools.com, and I'll drop a link to that in the description below. I also have a list of all the tools I use for each project, so please check those out. And while you're there, please hit the support link to help us make more projects and videos like this.
Here's the main parts of the mold: a base, the inset, the sides, the ends, and pipe holder pins. Cast into the concrete, there's a reinforcing stiff wire grid, PVC pipe, and wire loosely wrapped around the pipe. One sheet of 3/4 inch plywood is enough for 4 molds. I'll also need a length of 5/8 material 3 inches wide for the decorative inset, and a 4x4 that I'll rip into a 2.5 by 2.5 inch block to hold one of the pins. These pipe holder pins are made from 5/8 inch diameter doweling. I had my lumber supplier cut a 3/4 inch plywood sheet into 4 strips, each 14 by 48. I have a small table saw, so working with a full sheet is challenging. You can use a circular saw with a guide as an option too. I'll start by cutting these 4 bases down to the length of 43 inches. Then I lay out the design on each base. I'll use a black Sharpie to darken these pencil lines. I cut the rest of the 4x8 sheet roughly in half to make it more manageable. Once this is done, I start ripping the sidewalls from the balance of the plywood sheet. 8 pieces are required. I then cut these to length and label them Part B. Now rip the 8 side hold down strips and also cut them to length. There's going to be a lot of pieces to this build, so label the parts as you go along. On the drawing, you will find a scheme that I came up with that works well. For instance, all the sides are B, the hold downs for the sides are labeled C, and so on. The sides and hold downs are attached to form a right angle L shape with glue and screws. I pre-drill the sides on the inside face, 3/8 up from the bottom edge with a countersink drill bit. I draw a line and lay out the hole locations approximately spaced 8 inches apart. I clamp a stop on my drill press to speed this up. I also mark pencil lines on the stop as a spacing guide. I want the screw heads to be recessed into the hole. I'll fill these holes with wood filler later after assembly. I'll also pre-drill the side hold-down strips along the center line, spaced about 8 inches apart. Later during assembly, I'll use panhead screws to attach the sides to the base, which is part A on the drawings. Mark the sides and drill a 5/8 hole with a Forstner bit for the pipe support dowel. Set aside parts B and C. Now I'll rip and cut to length of the end walls. They are 2.5 by 8 inches and labeled E. These have their own hold downs. Rip and cut these to length and label part F. The ends and end hold downs get pre-drilled in the same manner as the sides and their accompanying hold downs. I make the pipe holder end blocks part G from a fir 4x4. I rip this on my saw using several passes from both sides down to 2.5 by 2.5 inches. I then cut these to 4 inches using a stop on my miter saw. I inspect these blocks, label the upside, and then with the square I mark the center of one end. I use a punch to make a small divot that will help guide the drill bit. I chuck a 5/8 Forstner bit in the drill press. I have stop blocks clamped to the table to help secure this block during the process. Drilling into end grain like this can sometimes cause the bit to wander, so go slow and allow the chips to clear. I drill this hole 1 inch deep. I now assemble the sides with glue and screws. I attach a stop strip to my workbench, and onto it I attach 2 hold down clamps. The clamps quickly and securely hold part C to the table. I also attached an end stop to align the ends of B and C. I apply a small bead of exterior wood glue to the side and press it into place. I drill a pilot hole into the hold down strip, then run in a screw. I then drill pilot holes through the side all the way down and secure it with screws. Check each assembly that the L shape is 90 degrees. Set these aside for the glue to set up. The sides have a small square stop block to hold the ends in place. Rip and cut these to length. Then pre-drill these as well. Now assemble the parts E and F. I marked the center of each to help with alignment, and also used the hold down clamps to secure the pieces during assembly. Like before, apply glue, drill, and attach with screws. Drill pilot holes into E and attach the blocks with glue and screws. Mark the side assemblies and attach the small square stop blocks with glue and short 1-inch screws. Next, we will make the angled inset. I used 5/8 material and beveled the sides 30 degrees on the table saw. I attached the inset part to the base by pre-drilling with a countersink, then attaching it with glue and short screws. I'll cut the 5/8 dowels to length and chamfer the ends on the disc sander. Cut a short test piece of 1/2-inch PVC electrical conduit. Use this to test fit the dowel pins. Use some sandpaper to slightly reduce the diameter of these dowels so the pin slips on easily. The inside diameter of the pipe is a bit less than 5/8. Glue these into place and let the glue fully set up. Fill the screw holes with wood filler. Let it dry completely, then sand smooth. Also fill any gaps in the plywood and add some filler to the inset where it meets the base. Give everything a light sanding to break any sharp edges. With panhead screws, assemble the mold using the layout lines as a guide. Check that everything is square, fits tight, and there are no gaps. If there are any variations with each assembly, you may need to try different part combinations to see what fits together best. Label each mold assembly 1 through 4, and also label each part assembly that goes on the base so you can reassemble them the exact same way each time you use them. Apply several coats of polyurethane finish, lightly sanding between coats. I used 4 coats of this durable flooring finish. Wet cement is very corrosive, so you want to protect the wood to get the most life from your concrete forms. Cut the PVC conduit down to length. And cut a 30-inch length of stiff wire and wrap it loosely around the pipe. This will reinforce the concrete and give it strength where it is the thinnest. This is where I remembered that not all 3/4 inch plywood is fully 3/4 inches thick. Most is now slightly undersized, and I laid out the parts for actual 3/4 inch plywood. It's an easy fix by adding some thin pieces of wood as shims. Once assembled, the molds need to be made watertight. I use a small bead of latex caulking to do this. Latex works well as it's not overly strong and will allow you to disassemble the mold easily once the concrete sets up. Don't use regular silicone for this. It's too strong and will be difficult to remove later. Latex caulk is all that's needed. Cut a section of concrete reinforcing mesh with small bolt cutters and have it ready to lay in the wet cement. This will make the concrete panels very strong. Place the molds on a strong and secure surface and level them in both directions. Once the caulking is dry, spray the mold with a releasant agent to keep the concrete from sticking. I used vegetable oil cooking spray for this. The 48-inch mold I made takes 1 bag of cement to fill. These new shorter molds will take approximately 3/4 of a bag. Have everything ready as you need to work quickly before the concrete sets up. I like to add a small additional amount of Portland cement to my mix to give it a bit more strength. I mix the concrete in a wheelbarrow and use cold water. Try not to make your mix overly wet. Too much water reduces the strength of the concrete, and this extra water may soak into the wood molds and shorten their life. It can take a while to get a feel for just the right mix. Now shovel the wet cement into the mold and fill it halfway. Then lay in the steel mesh and then fill it the rest of the way. Gently tap the mold with a hammer to help settle the wet cement and allow bubbles to come to the surface. Also, any tool that vibrates can work well to settle the cement. I have a drill with an impact setting that I've used for this in the past. Now cover the wet cement with a plastic sheet and leave for at least 2 days. Remove the hold-down screws and gently pry off the sides and ends. Gently lift the panel off the base. The concrete is still soft and will not cure to full strength for a few weeks, so be careful handling them. I use a paint scraper to remove the old latex caulking and a cloth rag to wipe down and clean the mold parts. I cut rebar into 1 foot lengths with a cutoff blade on my angle grinder. I clamped a long length of rebar across several sawhorses. A hacksaw will work for this, but it takes a lot longer. I level a spot in my garden and overlap 2 panels. For this box, I used 2 36-inch panels and 2 48-inch panels. I checked the corners for square then drive in the rebar through the corner into the ground to secure them. I repeat this on each corner to complete the garden box. We put a layer of cardboard down over the grass, then fill the box with compost and soil before planting. And your concrete garden boxes are done.
This is Kent from Man About Tools. Thank you so much for watching. If you like what you see, then please give us a thumbs up and subscribe if you haven't done so already. We'll see you next time.